What is closed system energy balance in thermodynamics? Have you ever wondered how energy behaves in a system that doesn't allow mass to flow in or out? This is where the concept of closed system energy balance comes into play. In thermodynamics, a closed system can exchange energy but not mass with its surroundings. This means that energy can only enter or leave the system into forms: heat and work. The first law of thermodynamics is the guiding principle here. It tells us that energy is conserved. In simpler terms, the change in the system's total energy equals the net energy transferred into or out of the system. This balance is essential for understanding how energy flows and transforms within a closed system. Now let's break down the components of energy in a closed system. The total energy consists of three main parts: internal energy, kinetic energy, and potential energy. Internal energy is related to the energy stored at the molecular level, which comes from the movement and arrangement of molecules. Kinetic energy refers to the energy of motion, while potential energy is linked to the system's position in a force field, like gravity. The energy balance equation for a closed system can be expressed as follows: the change in internal energy plus the change in kinetic energy plus the change in potential energy equals the heat added to the system plus the work done on the system. This means that if you add heat or do work on the system, its energy will increase. Conversely, if the system loses energy by doing work or releasing heat, its total energy decreases. To simplify this concept, consider a few assumptions. If the system is not moving, you can ignore the kinetic energy term. If the system's height remains constant, the potential energy term can also be neglected. Additionally, if the system is perfectly insulated, meaning no heat transfer occurs, the heat term becomes zero. If no mechanical work is done, the work term may also be zero. This energy balance is not just theoretical. It has practical applications. It helps us analyze processes like heating or cooling a substance in a sealed container or compressing a gas in a piston. Understanding this balance is also vital for engineers and scientists when designing engines and refrigerators, where the system boundaries are fixed and mass does not cross them. By applying the closed system energy balance, we can predict how much energy is required or released during various processes. This understanding is essential for ensuring that thermal systems are designed safely and efficiently. So, the next time you think about energy in a closed system, remember that it's all about balancing heat and work while keeping mass in check.